Okay, this is a corrections video for the ptvtat free response test. If you had this version that had a position time graph on it, this is the one that you need to correct. Okay, so first of all, we're starting out with a position time graph, and so let's talk about what these lines are telling us. So we have position on the y-axis, so I'm going to put in some arbitrary numbers here. So for position, I'm going to say this is 5 meters east of the origin, and this is 10 meters east of the origin. And here's a -5 and a -10. Okay? So I'm just making up numbers, but from these numbers I could say that person A, let's just say these are all walkers, person A at 0 seconds is 10 meters east of the origin. And a few seconds later, he's still at 10 meters east of the origin. And then he's still at 10 meters east of the origin, etc. So he's staying in that location. He's staying in that one spot. So he's at rest, right? Person B starts out 5 meters west of the origin, but as time goes by, he actually reaches the origin and then continues past the origin. And since we have a constant slope here, we have a constant velocity. Remember, slope on a position time graph is the same thing as velocity. So anything you say about slope, you can say it about velocity. No slope, no velocity. He's at rest. Constant positive slope, constant positive velocity. Let's see here, that was B. C. No, C is this line. C has a positive slope, but it's not a constant slope, it's an increasing slope. So if it has a positive increasing slope, in place of the word slope, I can say velocity. C has a positive increasing velocity. The velocity is increasing, he's speeding up. Okay, and then D has a constant slope, just like B, but instead of it being a positive, it's a negative. So somebody started east of the origin and was walking west. And then E is at rest, just like A, the entire time. E is at about -7 or 7 meters west of the origin. Okay, so don't get this confused with velocity. If this were velocity, A and E would not be at rest. They would have a constant velocity. But it's not velocity, it's position. So don't get your position and velocity axis mixed up. Okay, number 1. Which object is maintaining a constant non-zero velocity? Well, since it's a non-zero, that takes A and E out, because those are zero velocities. So it's got to be a constant velocity other than A and E, and B is a constant slope, and D is a constant slope. So if it's a constant slope, it's a constant velocity. Okay, which object is experiencing a constant positive acceleration? Okay, well, if you have an increasing velocity in the positive direction, you would have an increasing, you would have an acceleration. So here we have an increasing positive slope. So we have an increasing positive velocity. That means C is speeding up in the positive direction. So two positives give us a positive acceleration. Okay, which object has the greatest average velocity? Remember when we did our lab and we had, we walked and we jogged and we ran, and when we ran, that was the steepest slope. The steepness of the slope kind of gives you an idea of how high that velocity is. So the steepest slope on here is B. So B has the highest velocity. Okay, number 4. Which object is changing directions? In order for this to be changing directions on a position time graph, you would have to have a line, maybe something like this, that goes up, but it comes back down. It's got to have a positive slope and a negative slope, or vice versa. Okay? As long as it has one of each, and none of those do. None of them have two different slopes. Okay, for 5, which object is experiencing a negative acceleration? So it would have a negative acceleration if it is going in the positive direction but slowing down, or if it's going in the negative direction and speeding up. Okay? So D is going in the negative direction, but it has a constant velocity, so there's no acceleration there, right? Now, if that was a VT graph, the velocity would be a negative slope, and you'd have a negative acceleration. But again, don't get position mixed up with velocity. Okay, so that one's the only one that has a negative direction. B has a positive direction, but it's not slowing down. No velocity, and C is actually speeding up. So the answer to this is none. Okay, moving on to number 6. Sketch a VT graph of the 3 lines B, C, and D, and label each line. So I have to do a velocity time graph for B, C, and D. So first of all, B has a constant positive slope. Insert the word velocity, constant positive velocity. So B is something like this. C is an increasing positive velocity, so I have an increasing positive slope. And D is a constant negative velocity. And if I want to be really exact, I'm going to put my D closer to 0 than I put my B. And there we go. Okay, number 7. Sketch a position time graph for an object that starts west of the origin. Since this is a position time graph, this is location. So if this is 0, this will be west down here because that's a negative. So I'm going to start west of the origin, and I want to speed up toward the east. So it looks just like line C on the graph above. Not on this graph, but on this graph, because it's a position time graph. So it starts west of the origin and speeds up. Okay, number 8. Sketch a velocity time graph for an object with in a negative direction and slowing down. Okay, so here's my velocity time graph. In order for you to be going in a negative direction on a velocity time graph, it has to be in this region. Okay, if you have a negative slope on a position time graph, you're going in a negative direction. But over here, you have to be down here to be going in a negative direction, because this is not location. It's, hey, is it a positive velocity or a negative velocity? Okay, you can start on the positive side and walk to the negative side. Okay, so negative direction and slowing down. So I'm looking for this. Starts high, it's slowing down, so it should be something like that. Okay, and technically I really maybe should have said slowing down at a constant rate for it to look exactly like that. Some of you, I don't know if anybody did this, I can't remember, but some of you may have done something like this. Because I didn't say at a constant rate, then perhaps I didn't count it wrong, because that's true, but I was meaning at a constant rate. Okay. Number 9. Sketch an acceleration time graph for an object moving in the negative direction and slowing down. Okay, this is actually a VT graph being turned into an AT graph. A negative direction and slowing down. That gives me a positive acceleration. 2 negatives give you a positive. Positive slope, positive acceleration. Remember, slope on a VT graph is the acceleration. Okay, last one. Sketch a velocity time graph for an object with a constant positive velocity. It doesn't get easier than that. Constant positive. Okay, if you corrected your test, great. You can still print the other test and do it if you want to, but you have to turn in the corrected version to get your retake next class. The date that we're set to have the retake. I guess B-Day, you're having another test on Monday. Good luck.